Hi, welcome back. So we are in chapter 3, descriptive analysis, on the section of bivariate descriptive, and now we are on the last region of this graph to capture the relationship when you have two variables. One of them is discrete, the other one is continuous. Now, in order to understand, I have come up with the direct example. Now, x1 happens to be dichotomous, two possible outcomes, either 0 or 1. x2 happens to be a continuous. Now, we have two cases of x1 that could be 1 and that could be 0. The possible value of 1 in ascending order. There was 6, there was 10, 11, etc. And then the same thing I did for the zeros. Now, first of all, what is the proportion of 1? Happens to be 50 because there are 5 out of 10 other are 50%. Now, next thing I did, I considered this as if it is completely a new vector, like on its own, a new variable. I call it y1, for example, and I call this one y2. The mean of this new created subvariable 10, the mean of this happens to be 2.4. Next, I transfer this into a kind of just a graphical, maybe not too much intuitive, but it can show you something. Now, this is the case when it happens to be 0, for example. These are the possible values. We see them 1, 2, 2, 3, 4. And these are the dot I put them. Now, this dot are quite a bit fatter than the other because there were two values of 2. So you can see the region category of 0. So you could see the other region is in here. Now, by eyeballing, I can tell you, there seems to be a real good, strong relationship that can indicate a changing of this categorical value from 1 to 0 or from 0 to 1. It indicates a changing in the values of the continuous. But to capture this mathematically in an intuitive way, we use this point biserial correlation. And this, by the way, happens when you have your discrete value to be binary possible value. So the calculation simply take the mean of the first group, the mean of the second group, and then multiply by the square root to quantity. The first one is the proportion of the first group and the proportion of the second group. Then divide by the total standard deviation of the variable that is continuous. In our case, happens to be x2. Now, if I plug all the information I have down here, I already have the mean of the first group, which is 10, 2.4, the second group, multiplied by the proportion of the first group, 50, and the other one, 50, take square root, divided by standard deviation of this continuous value happens to be 4.37. So you could see the correlation happens to be 0.87, and it's quite explainable in this image. Let me show you another case. Now, I've got this case where you've got, again, x1 and x2, but the difference here that happens that x1 have A, B, and C. And what I did again, I just considered the A and B and C, and I place down the values down for you here. And then again, I draw this graph. Now, looking at this graph doesn't really seem the relationship between x1 and x2 is intuitive in any way. So what I decided to do is something that you might be familiar with. I decided to take this continuous values, creating two groups, 1 and 2. The first group, it contains all the values from 1 to 5, and second group from 5 to 10. Of course, you know how this table has been constructed. A happens to have 4 values between 1 and 5. The second group have 0, nothing of A. B happens to have 0 of values between 1 and 5, but happens to have 2 between 5 and 10, etc. Simply, I calculated the marginal counting and the percentage. Now, what I did, if you remember, how did we calculate the correlation? In this case, you are very much familiar. You may go back and check when we calculate correlation between two discrete values, and what's quite clear to you. If you do this, you will get a value of 0.1. So this is the covariance, and it's quite clear. It's a very small value. Again, we take the covariance and we capture the correlation by this equation. If you do that, you will get 0.30 correlation. Correlation can average between this interval, and it's somewhere around here because the relationship does not exist. Now, if you like, also you can do a box plot analysis. So this is a continuous value, x2. This x1 happens to have 4 different groups, so it could be A, B, C, and D. that was the ending for the study of bivariate descriptive analysis. Next, I will share with you a quick conclusion on the bivariate descriptive analysis. So I will see you then.